Yours doesn't have to look exactly like this, but it can. Doesn't have to be called loop. It can be called whatever. I called mine counter. Started it at 0, which I just realized I should have started at 1. Oops. And then we just pass in another one recursively forever. Okay. Cool.
So you did the io.inspect there.
Mm-hmm.
So what is the difference between that and puts? Puts like a print.
So in this case, we could have just done puts. It's the same.
It's
Yeah.
the same. Like,
Yeah.
exact thing.
Yeah, so io.inspect is io.puts, inspect whatever's in there. So in this case, because it's a string, inspect turns things into strings. So it could have just been puts. You're right. Yeah.
But if
Yeah.
it's not a string, you need to do.
Yeah. Yeah. You need to either explicitly say inspect this thing or io.inspect.
Okay.
Yeah.
Cool. So inspect casts whatever it is to a string.
Converts it to a string.
Converts it to a string.
Yeah.
Okay.
Yeah. It's like having a show instance.
Okay.
Yeah.
Okay.
Yeah.
Thank you.
Yeah. No problem. Okay. All right. So good news. You just wrote agent, which is another module. Right, so agent is just a simple state manager, kind of like count. Actually, before I get going too far, is it working? Yeah. You think so? You sure? Like yeah? The files, yes. Okay. Okay. Well, I'll keep barreling ahead. So it's a simple state manager. So when I've mentioned a few times, you might want to put state out into a process that we can then, if another process dies, it's not a big deal because the state still lives over there. It's like our own little database, right? And all this process does is it handles some state, holds on to it, lets you send functions to it to update that state, and it can send you the state back. So I have these 3 processes, and they all want to write to the same, log. So we can have our little agent log in here, and they just all send it the same, all sends it their messages, and it's just going to update. So there's more functions than this in the module, but these are the main ones. Start link or start, depending on your preference, to get it up and running, get to return you the state, and update to update it. When you cloned in uprun, it came with a complete copy of War and Peace, believe it or not, under priv. This is a word counter that's totally concurrent. So instead of going through every word and tallying them up, we're going to split War and Peace into chunks of 500 lines, pass those out into each of their own process every 500 lines dynamically, split each of those at spaces, clean it up a little bit, and then update my agent, which I'm naming here tally, with this updater in a map. Okay. And sorry, this is the naming, not this tall. The naming is this process.register agent, which is my PID for the agent. I'm going to call it tally. Okay. And now I can globally refer to it as tally. It's not the greatest. You don't want to name them too often because you can have a namespace conflict, and there can only be one, right? But in this case, it makes sense because we just want to, we're being lazy for reasons of demonstration. So for results, I will ask tally for everything back, the entire. This is a little identity function, fnx to x. When I call the frequency on it, I'm going to agent start link with an empty map. That's the chunking and the splitting out into new tasks. And that's my update function. And I can even run this to prove it works. Now that I said that, it's not going to work. Where am I? No, it's the wrong one. It's also the wrong one. And we could run this in Observer too, but it's actually, it's going to be too fast to actually see it. Or you know what? Sure, why not? Because I'm running this interpreted, it's going to be a little slower. And done. And now if I want to see the results, so this blocked my main thread while it was running because I was doing all of that frequency stuff, you know, starting new processes, whatever, in this process. But I was saving it to an agent. So I had a couple thousand processes writing into that agent. So I can say word counter.results. And this is every word in War and Peace, and the number of times they occur.
Why are some of those less than,
Yeah.
Why did it not?
Yeah. So in some cases, we're going to have accents and other values that it can't handle and print the way that I had written it. You can have it handle these characters and have it print normally. But because the encoding that I was doing this with was on ASCII, it's printing these out as just bit streams because it's like, I don't know the encoding.
Oh.
So I can...
By default, everything was encoded.
by default it is, but I was doing it for speed.
Oh.
Yeah. So. Okay. All right, so using agent, write a little to-do app where you can just add a new item, set an item as done, get one, sort the list. Don't worry about that, and reset. But yeah, this isn't object oriented, but like it's not that far off at this point, really. I'll rewind to an example of agent, but you should be able to add items into it. Add items, get items. You don't even have to do this as a module. You should be able to just do agent.start, grab the PID, and just start putting stuff into it. If you want to do it as a module, feel free. All right, so we're going to move on to projects. So, starting out, let's talk about hex. This is hex.pm, kind of like how you had hex.docs.pm. This is just hex. And this is where you can find all of the packages that are written for Erlang or Elixir. And let's start creating quick chat very slowly. Okay. So open up your terminal and type in mix new quick _chat. And also just as a quick time check, it's 2:45, 3 o'clock is the afternoon refresh, coffee. Last few years they've had snacks as well. I don't know if they're doing that this year. I'm going to aim to get us out of here a couple minutes ahead of that so we can beat the line. But yeah. But yeah, so mix new. So mix is the task runner, build tool, etc. And mix new is going to create us a new project so that we don't have to keep loading these, C and then our specific file. And that's going to create for us a whole bunch of files. We have a README, this formatter.exs, which you probably will never need to actually go into because it comes with the community standard formatter. Formatter is still a little bit controversial because it's fairly new. when you run mix format on a project, it will reformat everything. So if you have pipes at the end of your line, they'll end up at the front of the line. All of that stuff. Git ignore, obviously. Anything with EXS on there just means that, so it still gets compiled when you open it up in IEX, but it doesn't save the build. So it's just for things that you're going to throw away. Mix, which we'll look at in a moment, is where you specify the name of your project, dependencies, version of the compiler, all of that. Config, we're not going to look at too much. That's where, let's say you have a database in your application, you can configure your database in the config. Everything that for your actual application or library lives under lib. And by default, you get the same as the project name .ex. There's also a test folder with the helper, and that really just sets things up. And then one test file as well. To test, you run mix test, and it runs all of your tests. That's how the tree looks. Right? 3 directories, 6 files. Pretty simple. Go ahead in your text editor, open up mix.exs, and it'll look a whole lot like this. Right? Every language does it slightly differently, or every system. It's a regular regular module in Elixir, quickchat.mix project. The convention in a project is to have the name of to namespace everything. So quick chat will start everything else. We have this use mix.project, and that's a macro, and it's going to spill a bunch of stuff in here that we don't want to see, that we don't care about, but it's going to help the build system set up. Def project sets up an atom for your app, the version that this is, so when you publish it to hex, it'll be 0.1.0. Version of Elixir, the squiggly arrow means at least 1.6 dot something. Start permanent means that, check if that's prod. And deps, because this is all done in a regular module, we have access to all the usual stuff that we would get in Elixir. So we've split this out into its own function by default called deps that returns, well, right now, an empty list. But you could uncomment these if you wanted to. So let's compile it. Mix compile will compile your quick chat app. And IEX-S mix is going to supervise your mix. Right? So pulls everything in by default, and then you can just say quickchat.hello, which is the only function you get by default, and it'll return world. And that's just a regular module. In fact, if you go into lib/quickchat.ex, you'll just see def module, quickchat, def, hello, and it returns world. So I'm going to show you this exercise in interest of time because we really want to build quick chat. I'll just run you through what it is and kind of roughly the solution. So has anybody seen Calce before? Yeah. So there's a Calce package, obviously, on hex. And in this case, we're going to make a little madlib where you have some text and you just leave some blanks, you accept four strings, and it'll just print them out like that, and then have a cow say it, right? Those would live, the dependency in this case would live here. It would be, as a tuple, colon cow say, comma, and then whatever the version is on hex. Right? For behaviors, yes. Okay. All right, behaviors. So this is one of two kinds of polymorphism. This is module level polymorphism that we have in Elixir. It is spelled with a U, so the Canadian spelling for once. And all it does is it says you have to define these functions with these types, right? They're called callbacks. And just we have a module with these functions in it so that I know that, we do all this dynamic function invocation, right? I can pass you a module and I know I can just call these things on it. It's not object-oriented because there's no, by default, no state held in the module, right? You could spin that out into an agent and then have the module handle that agent, but it's really just a way of saying this is a common interface for these modules. Right? So here's a example that doesn't actually exist. This is just something you could do with it. I'm going to have a module. I'm going to define 3 callbacks on it: serialize, deserialize, and valid question mark. I have these types that I say it has to adhere to. So valid, for example, takes a string and must return a Boolean. Deserialize takes a string and returns either OK and something that has been deserialized into, or error, as in Atom. And it doesn't have to be just callbacks. You can also define regular functions in this module as well. That could say call out to that module and call things on it. So module.deserialize. Right? So we can pass it in dynamically and have it just work normally. This is an example of something that is serial. You say at behavior, and then the behavior that you're implementing. I have deserialize, serialize, and valid, just like it says up there. Right? Pretty straightforward, right? We just have a couple functions that have an interface. So one example of something you could do with this that I haven't actually seen, but you could, is define like a CRUD API, right? All, get, put, post, right? You could define those as callbacks and then have different modules implemented so that you could have one that just runs locally, one that's an actual web server, etc. So what's so great about behaviors? Because GenServer, a generic server, is a behavior. And this, when we did agent, when we did, well, a lot of things, and really the rest of this workshop is all going to be in GenServer. Agents are a GenServer inside. It's just a nice wrapper for one use case of them. It has, there's more callbacks than these, but these are the ones that people really care about. Init for when you're starting up, right? Give me some starting states or log, yep, I started up, something like that. Handle call is synchronous. If I call handle call on a module with this behavior, it will run this and wait for a response. Handle cast is the same thing, but it's asynchronous. So fire and forget, I did my part, it's over there doing its thing now. And handle info is if it can't match any of these, it'll do it with the info. We're not as worried about that for what we're going to be building today. We're going to be spending most of our time in call and cast. So this is an example of a, I'm going to bump the size on that a little bit too. This is a database done in GenServer. I have 2 halves. The client API, which is for me, the user, But that has nothing to do with the behavior. This is, right? So this is the server API. I've defined init to take OK, so that when I start this up, I have to pass it OK. And I'm going to return OK and an empty map. When I say get all from my state, which I'm calling store, so this is defined by the behavior, right? That it always has 3 arguments. The message, who it's from, and that'll get sent to you automatically, and the previous state. And then you have certain responses that you can give back. Unless something's gone wrong, you do reply, and I'm going to return them the store and update my state with, well, this is a get, so I don't update it at all. I leave it as is. When I want to get just a particular key, I can pattern match, say get this key from that store, reply to the caller, get out of my map that key, and don't do anything to the state. Just leave it as is. Handle cast, I'm going to say is asynchronous. Right? I'm not waiting for any response back. I'm just going to say, hey, set this key to this value, key value store. This has 2 arguments instead of 3, because I don't care who it's from. Okay? No reply is the contract, the interface. Put this in the store, key value. Okay? This top bit just cleans it up. Right? So when I say GenServer.startLink, I have to pass it this OK. This underscore module, underscore, is a meta variable for the name of whatever module you're in. So I could have just written mydb there. Set the process ID. So it's not that we have mydb that accepts these messages as methods. I have to send a message to a process that has been started with this interface, right? With that start link. Set key value, and that's going to do this .cast, hence handle cast. Set key value, set key value. Get PID and key, same thing, get key. Get key, and then get all, get all. Now, I wrapped these all in tuples just for consistency. You don't have to. You can send it anything as a message. Yeah, it's just convention if you want it. Make sense? Okay. So again, this is what's going to get run in a process somewhere else, and this is an easy way of interacting with it.
Could you set those server APIs as step P? So people aren't.
Sorry, which ones? Oh, server API as what?
Oh, never mind. I was asking if you could set the bottom ones as step P, but I guess you'd still need to access them.
You still need to access them, yeah. Another pattern that's starting to emerge, though it is newer, is you split these into separate modules. So you'd have mydb with the client API, and then mydb.server with this stuff, right? And then you would start link with mydb.server. Right. Yeah. Or, sorry, I should not use my own. There, okay. Is it MyDB? I think it is. Yeah, there it is, okay. Right, there's the DB. And I can mydb dot. Oh, you're not seeing my screen because I didn't mirror the display. Thank you. Okay, all that typing you were hearing was this. Okay. And what do I have here? MyDB dot set. I have to pass it the PID, right? Oh, and that is cut off. I have to send it the PID, right? The key that I want to set, and the value. Right. And then I can also get A, and there it is, right? So feels weird coming from an object-oriented background because I'm saying get from the DB this thing, not DB give me this. Okay. It is break time. Go, enjoy. I'll see you back in half an hour.